This is lesson 3.5. Proving lines parallel. Right now, students are working on these 3 warm-up problems, so go ahead and try them. I'm going to give them about 1 more minute before I go over them. Okay, I'm going to start with number 1. We were given the slope, and we were given a point on our line. Is that point the y-intercept? No, otherwise it'd be 0, 10. So I just have a random point, which means I have to use point-slope form. Okay, I'm not going to write out point-slope form every single time for these, but you got to make sure you know it for your quiz. I'll write it up here. It's y minus y1 equals m parentheses x minus x1. And the reason why I have to use this is because of the given information here. I'm given a point, given the slope, not given the y-intercept. So I can't jump right to y equals mx plus b. That's what form they want me to write my equation in, but I have to start here. So I would do y minus the y-coordinate, that's what y sub 1 stands for. The y-coordinate of the point is 10, equals m, slope is -1, x minus x sub 1, the x-coordinate of the point, so minus -4 would be plus 4. Now, if they asked me to write my equation in point-slope form, which some of the ones on the quiz you will, I would just leave my answer like this and be done. Okay? But here they wanted to write it in slope-intercept form, so I just have to solve for y. So this one isn't too bad. You just distribute the -1 and then add over the 10. So you end up getting -x. If you have -1x, that's fine, plus 6. Finished, remember?
Yep.
Okay. See you later. All right, so there's number 1. I'm going to come back to number 2, since that one seemed to stump us a little bit. Number 3, the only information I was given were the 2 points that this line passes through. But I can calculate the slope between 2 points. I've been doing that for a while now. I just find my change in y, so the difference in my y-coordinates, over my change in x, the difference in my x-coordinates. All right, so I would do -6 minus -9. All over 4 minus -2. Ooh, lots of negatives going on here. Minus negative is the same as plus positive. Oh my gosh. Plus positive. Sometimes I just really get mad at my surfboard. Okay, let's try this again. Plus positive, plus positive. I think I wrote too fast. So here I end up getting a +3 over +6, which reduces to 1/2. Okay, if you got that far, great. Now I need to ask myself, am I given the y-intercept so I can jump right to slope-intercept form? Are either of these points my y-intercept? No. Okay, so I got to do point-slope form again. Y minus y1. Which point do I use? Either or, it doesn't matter. I'm going to use this one. So y minus -6 would be plus 6 equals m. Slope is 1/2. We calculated that. X minus x1, since I use this point, I'd have to use 4. Okay, if they asked me to write this in point slope form, I'd be done. And some of the ones on the worksheet, I wanted you to leave it in point slope form. Slope intercept form, distribute the 1/2. Half of 4 is 2. Subtract over to 6. We got y equals negative 1/2 x minus 8 for that one. Anybody 2 for 2 so far? All right. I'll be impressed if you can get this one. It's just a little bit more challenging. We did something like this in class, but the ones in class, the equation that was given to us was already in slope-intercept form, and this one's not. That's what makes it just one little extra step, okay? So although they don't say what the slope is, they are telling you what the slope is by telling you this piece of information, that it's perpendicular to this equation, okay? We don't know what the slope of this equation is because it's not solved for y, right? It's not in y equals mx plus b form. The slope is not 2. It's not always just a number in front of x. So let's quickly over here, let's solve this equation for y. Move over to 2x. Divide by 3. And I get negative. We always want to keep our slope as a fraction. And 12 over 3, that's 4. All I did was I took that form, this one's in standard form. We probably talked about standard form in Algebra 1 where x and y are on the same side. I took that equation and I just rewrote it in slope-intercept form. Does this help you figure out what the slope of this line is? Yes. What's the slope of this line? Negative 2/3. Thank you, Alejandro. Negative 2/3. If our line is perpendicular to that line, our slope is going to be the opposite, so positive, reciprocal, 3 over 2. That's what the slope of our line is going to be. Now I know the slope, and I know a point. Negative 2, negative 8, is that the y-intercept? No, they never really give you the y-intercept. Of course not. So I'm going to have to do point slope form. Y minus, I'm going to use this as y on the next one, minus negative 8 is plus 8 equals, m, we're using 3/2, x minus x1 negative 2 plus 2. Again, if the direction said write your equation in point slope form, I could just stop. To write this in slope intercept form, we would distribute. So for y, 3/2 x minus 5 is the equation of our line. Anybody get that one right? Oh, nice. There's a handful. Air 5s. Okay. That's a good review for the quiz tomorrow. We'll talk about the quiz at the end of class. I have a little review sheet to give you. So today, this lesson kind of plays off of lesson 3.2. All right? In 3.2, we learned about alternate interior angles, corresponding angles, and all of their relationships if the lines are parallel, right? Consecutive interior angles always add up to 180. Alternate exterior always congruent, etc. So today we're going to do the converse. There's a good chapter 2 review term for you, where we know information about the measures of the angles, and we're going to use that to prove the lines are parallel. Okay, so we're taking a bunch of postulates and theorem that we've already learned, and we're just talking about the converse of these theorems. So we're exchanging the hypothesis and conclusion. All right, so this I copy and pasted from your old notes. We know this. We know if 2 parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. Okay, here are some examples. 1 and 3, corresponding angles. 8 and 6. 7 and 5, 2 and 4. If those lines are parallel, which that's marked for us, we know those are congruent. If hypothesis, then conclusion. The angles are congruent. So the converse of that theorem we would exchange the hypothesis and the conclusion. So we'd say, if they're combined transversal, if the angles are congruent, then we can conclude the original hypothesis that they're parallel. Okay, it works in the converse. All right, so this example, so you can see this is labeled the converse of the corresponding angles. This is the one we already know. This is the new one for us. If you want to put a little star by all the new ones, you can. This one's new. So if we know, like in this picture, any pair of corresponding angles, I'm just going to use 1 and 3. If we know those are congruent, then we can conclude the two lines, in this case, are talking about A and B because that horizontal line is my transversal, then those two lines are parallel. All right, you don't have to use those two notes. You could use 8 and 6 if you wanted to. Same thing. If you know a pair of corresponding angles are congruent, then the lines are parallel. We call that corresponding angles postulate, converse, or converse of corresponding angles postulate. All right, so corresponding angles, that's one relationship we know. Another relationship we know with parallel lines are alternate interior angles are congruent. Okay, as a refresher, alternate interior angles, meaning they lie inside the two parallel lines, opposite sides of the transversal. Here's what we already know. This one is copy and paste from your notes. This is not new. If we know these two lines are parallel, then we can conclude each pair of alternate interior angles are congruent. So 1 and 3 are congruent, 2 and 4 in this example. That's what we know. Here's the new part. So put a little star by this one. I did not mean to move that. Here's the new part. The converse. If we know the angle measures are congruent, like in this example, 6 and 8, then we can conclude the lines are parallel. So obviously, anytime we're trying to prove that something's parallel, we're going to use the converse, because that's the conclusion on all of these converse, because before that was normally like the hypothesis for all our theorems, right? Like if these two lines are parallel, then these angles are congruent. And now we're just interchanging those. If we know relationships about the alternate interior angles corresponding, if we know those are congruent, then we can go in the other direction and say that they are parallel lines. Okay, 2 more to go. What do we know about alternate exterior angles if the lines are parallel? Those are congruent, right? So if the two lines are parallel, alternate exterior, such as in this picture, 5 and 7, 6 and 8, alternate exterior angles are also congruent. So in the converse, so here's the new one for us, the converse, if we know a pair of alternate exterior angles are congruent, such as in this picture, if angle 1 is congruent to angle 3, then we can conclude the two lines that's cut by the transversal are parallel to each other. Okay. Last one. Here's what we already know, copy and pasted from your old notes. If we have two parallel lines, what's true about consecutive interior angles such as 1 and 2 in this picture? What's true about these? They're supplementary, yep. They're not congruent, but they add up to 180, right? Consecutive interior angles. 1 and 2 and 3 and 4. So the converse, if we know a pair of consecutive interior angles are supplementary, so in this case, if the measure of angle 4 plus the measure of angle 5 equal 180, then we can conclude the two lines are parallel. In this case, P and Q again. Okay. So there's all the notes part for today. The rest are just going to do some examples. using the converse theorems. Using information about the angles to prove lines are congruent. Or lines are parallel. Lines are parallel. Okay, let's try one. Given angle 1 is congruent to angle 3. All right, I'm just going to go ahead and mark that. So I know angle 1 is congruent to angle 3. Is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. All right, if it helps you to kind of like highlight the transversal, so the line that's intersecting all three of these lines is the green one. And sometimes it helps students to like extend it too. There's my transversal. So obviously, angle 1 is made up with the transversal in line A. Angle 3 is made up of the transversal in line B. Okay, so we're trying to prove A and B are parallel. So if I know that these are the same, what's the relationship between angles 1 and 3? Ben? Corresponding. So if they're congruent, the corresponding angle converse lets us say then yes. If you know those are congruent, angle A would be parallel to angle B, corresponding angle converse. You don't have to write out postulate. All right, this next one goes with the same picture, same diagram. This time we're given the measure of angle 1 is 103 degrees. Okay? Measure of angle 4 is 100 degrees. So now we're kind of looking at, I'm going to erase this. Green is still my transversal. Now I'm looking at if A and C are possibly parallel. Okay, so 4 and 1, what's their relationship? Alternate interior, good. And in order for these lines to be parallel, the alternate interiors would have to be congruent. Are they congruent? No, right? No. Angle 1 and angle 4 are alternate exterior angles. Or, oh gosh, I cannot talk today. Alternate interior angles. If A was parallel to C, then those angles would have to be congruent. And they are not congruent. Something like that would be a good explanation to have in your notes to look back at it, explain why we cannot justify that those are parallel. Cannot conclude would be a better word. Okay, let's try another one. Do diagram here. Given angle 1 is congruent to angle 5, is it possible to prove that any of the lines shown are parallel? All right, so I'm looking here, and it looks like line P is my transversal. That's a line that's intersecting all of these. So they're telling me that angle 1, which is made up with the transversal and line L, is congruent to angle 5, which is made up of the transversal and line N. All right, what's the relationship between 1 and 5? Corresponding, yeah, corresponding. So since they're congruent, the corresponding angle converse lets us say that line L will be parallel to line M, corresponding angle converse. That's it for that one. All right, next one says, given that the measure of angle 4 is 105 degrees, so that one is made up with line M, and the measure of angle 5 is 70 degrees, is it possible to prove that M and N are parallel? Because those are my two lines I'm looking at now. All right, what's the relationship between angle 4 and 5? Nice, Wyatt. Consecutive interior. Consecutive interiors have to have a total of how many degrees? 180. Do these total 180? 105 and 70? No. Close. No. Angle 4 and angle 5 are, just like Wyatt said, consecutive interior angles. If those two lines were parallel, then those two angles would be supplementary, or you could say they'd add up to 180. And 105 plus 70 does not total 180. Okay. Yes, sir.
In the first one, isn't it supposed to be yes, L is
Oh, to N?
Yeah.
Yeah, you're right. Sorry. That's supposed to say N. Good catch. Thank you. In number 1, it's supposed to say line L is parallel to line N. Thank you, Ben, for the correction. Okay. 4 to go, people. This time, they want me to find the measure of angle ZYN so that PQ is parallel to MN. Show your work. Okay, I'm going to highlight angle ZYN. Remember, the middle letter is the vertex, so ZYN would be this one. Which right now they're telling me that's 7x plus 35. And they want me to show PQ, this one, is parallel to MN. Okay, so looking at the other angle measure here, I know this angle up here is 11x minus 25, and then the one I'm trying to find is 7x plus 35. What's their relationship? Alex? Why?
Because 11x minus 25 is vertical to x, and x and y are
Oh, I see what you're doing.
yeah, because x is also congruent to 7x plus 35.
Okay, corresponding.
Yeah.
Yes, there's an easier way to just relate these two. Matthew, you're not wrong.
Alternate exterior.
They're also alternate exterior, right? But what you said was perfectly fine. She said these are vertical, so they're going to be same. These are corresponding. That would work too. Alternate exterior are also the same. States that those two angles are congruent. So we can set up an equation. I have to find the measure of ZYN, but so first I got to solve for x. So subtract over the 7x. Okay, add over 25, we get 60, divide by 4, we get x is 15. All right, from there we just plug that in to ZYN, which is 7x plus 35 degrees. X is 15. What do we get? 140? Okay, so that angle would have to be 140 in order to make lines MN and PQ parallel to each other. Which means PXW would also be 140, right? Okay, this one, I got a new diagram. This one, they just want me to find X so that GH is parallel to RS. All right, I'm gonna highlight in blue here my parallel lines I'm trying to prove. This one and this one. So here's my transversal. Alrighty, folks, what's these two angles' relationship? Alternate interior, which means they should be congruent or the same. Okay, so using the converse, if we can show these measures are the same, then we can conclude they're parallel. All right, another equation here. Minus 7x. Add over 21. Divided by 2. We get x to be 9. And that's all we had to do for that one. And just find x. So when I plug that in there, I would get both angle measures to be 60, right? Yep, 60. So then the alternate interior converse would allow us to say these are both 60, then those two lines are parallel. Great. Okay. Again, we need to find x. This time, we want to show line M is parallel to line N. All right, so here's my transversal. What are these relationships? Consecutive interior. Consecutive interior converse says that if those angles add up to what, folks? 180, yep. If they're supplementary, then you can conclude those are parallel. Okay, so I'm not setting these two equal to each other. These are consecutive interior. These should total 180. Good old-fashioned algebra here. I don't mean to go too quickly. I've done a lot of this, and you guys are pretty good at solving equations. We get 22. Okay. Last one here. Is it possible to prove that the backrest and footrest of this lounging beach chair, don't you wish you're on a beach somewhere? If they are parallel. If so, explain how. If not, explain why not. Okay, so I'm just going to highlight the ones we're trying to prove parallel here. So they said the backrest, this, and if it helps you to extend it, you can, and the footrest. So you can't just say, yeah, they look parallel to me. You got to use some geometry here. So my transversal, or like the other piece that's making up the other two angles, is kind of like the bottom of the seat, right? So I might kind of help you to do that as well. Extend that. All right, so they're showing me that this angle right here with the backrest and the seat is 135 degrees, and this angle right here with the bottom of the seat, so the footrest, is 135 degrees. What's the relationship between those two angles besides that they're congruent? Yeah, they're alternate interior angles. So if alternate interior angles are congruent, then the two lines are parallel. That is the alternate interior converse postulate. That would state, yes, those are congruent. Or, oh my gosh, I keep saying that. Yes, those are parallel. Oh, it's been a long day, folks. It's only Wednesday. We're going to do the construction quick. Are you guys okay with just me doing it on the dot cam instead of getting out the constructions? I'll just kind of show you the construction quick. It's kind of a fun one. If you want to go grab a tool, you can. They're back there if you want to follow along. But we're just going to quick do one construction of how you can draw parallel lines. So we have time to do this. Get this set up here. Okay. Somebody wants to do it?
Is this going to be another extra credit question on the test?
I don't know. I didn't look at it.
That's what it was last time.
Does that change your mind?
No, that's the midpoint.
What was it? Midpoint? Whatever one it
Oh, it was
was.
a perpendicular bisector, wasn't it?
I don't remember. I just remember like you had some cheeky question on it. Cheeky question.
Okay, watch me learn. All right. Here is how you can construct two parallel lines. Okay. You're going to start by drawing a line. And just to follow along with the notes, they want us to call this line AB. Okay, I need to zoom in a little bit, maybe. A little bit bigger. All right, then we're gonna put a point, not on our line, call it point C. So I'll just do this up here, point C. Then you're gonna draw line CA. All right, so essentially what we're gonna do is we're gonna construct angle C to be like a corresponding angle to this one. We can construct a corresponding angle up here, then we can draw the parallel line. Okay, so remember how we draw an angle? You put this at your vertex and you kind of just draw an arc anywhere. So that right here, draw an arc. Okay, if I'm trying to copy an angle, so I copy it on my new vertex, draw that same arc, make it a little bit bigger. There we go. And then you use this as like a measuring tool to measure basically like how wide that angle is. Draw a little arc there. Okay, to show that you measured it. And then you're going to do the same thing here with line C. This way. Okay, I need to make this arc bigger. These should intersect. All right, I need to make this one bigger. Hold on. This one from point C. This one. Oh, I think I just moved it. Is it still on the dot cam?
Yeah.
You can still see it still. I didn't go off the page. Okay. I just need to make this arc bigger. There we go. Okay. Hopefully that kind of makes sense. So I'm just copying this angle here. They want me to call this point of intersection E, this point of intersection D. So essentially what I just did was I copied angle CAB up here, draw a line through here. I copied this angle to be this angle. So now they're corresponding angles, meaning that these are parallel. Okay? So again, I'll just go through that because I kind of, I drew an arc here, use this to measure anywhere on your angle, doesn't matter, intersect those arcs, copy the angle. We've copied angles before, so now you're just basically copying it to make corresponding angles. Dun, 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 dun. There you have it. Okay.